Okay, finally I was able to sit down and create a video for you. Like the last 2 weeks has been a bit interesting, a bit like frustrating, for two reasons really. It has been really difficult to get moving with this components concept because it didn't actually work last time. Because it's like what I'm trying to do is to create a component concept inside Snubdom, and I'm going to show you how it works. But it's actually a bit tricky because you might get reconciliation from a parent and you might get reconciliation from the inside. And it's kind of hard to wrap your head around how this should actually work. So I had like lots of iterations and trying to understand Snubdom and how it manages this component concept. It's been times where I almost gave up a couple of times. Like I ruined date night last week. I spent a whole day where I was supposed to work on Code Sandbox. I spent like 12 hours working on this. And just a big shout out to Fabrice, who's been helping out a lot generally with Overmind and stuff, for just listening to me. I've been using him as a rubber duck and kind of like writing down my frustrations and all this stuff. But now I've gotten to a place, and it's really nice to have the Overmind dev tools to test this. Because it's like a super complex in terms of rendering. There's like tons of nested recursive components and stuff. And there's so much information coming in there. So it updates a lot, and some of it updates from like a parent, and then it updates from inside. And yeah, it's really complex stuff. But anyways, I'm even more confident now that it's working. So what I thought we could do first is I can just talk about the concept in general. So Overmind components is going to be a concept where we think about the state store first. So traditionally, component concepts has been about the components, and an external state store has become like a secondary thing. In Overmind, the state store is the primary thing, and the components, the view, is just is the secondary thing. And what does that do with like the mental image and the developer experience? That is what I'm like exploring with this concept. So anyways, the idea here is that it is based on React in terms of JSX syntax and typing and all that stuff. So the way you set it up is that you use the bubble plugin transform React JSX, and I'm going to use, in the DevTools I'm not currently using OC, but I think that will be the best because we can also have fragments here, and that's just the best way to set that up. Yes, so anyways, when you create a project with Overmind components, you create your Overmind instance, and then you render out the instance of Overmind with your initial component and some container. That's basically it. And then all the components will have that Overmind instance as part of the context of the component. So this is great for testing as well, because then you would just render the mocked version of Overmind, for example, and whatever component you want to test. Yes, and then we have the component itself. It's just a function. What's special about these components compared to other components is that they return this self element, and the self element refers to the component itself. And that means that when you look into the DOM, you will see that my dash component is an actual element. And that is what this self element is. And I think this is a really nice thing working with the dev tools. Like things like styling become so much easier. So by default, these component elements, they don't actually affect the painting or like the drawing of the page. But you can make them do so by styling them. And typically you have these container or wrapper elements in components, because you really want the component to be a concept of the page. So for me, this makes a ton of sense, and it's so much easier to understand the styling, because if you have some element that doesn't show the way you want it to, you can just point to it in the DOM, and then you will actually see your components in the DOM structure. So it's so much easier to reason back to what component actually is responsible for this element. And then, of course, they can receive props, which is the exact same concept as normal components. And then we have this second argument. So the first argument is the props, and the second is, like, it's called context, because it's called that in React, where you now have app state, which points to the Overmind instance, and you have actions. So you just use it. You don't have to think about connecting it. Like with React, for example, you have the use Overmind hook. You don't have to think about that at all. You can just instantly use it. And if you had typing here, like, you could type the component and you would get all the typing. And then there's a question, like, you do need internal state in components. I don't understand how you can go without it. So an example of this is here, for example, we have this value inspector. And this value inspector needs internal state. It needs to know what of these paths are open. And this is a completely reusable component, so you can't have this as application state, because then you would need a reference to all the different value inspectors and control the state there and know when they unmount and stuff. It would just be super problematic. So I wonder, like in Elm, for example, how would you create this value inspector? Would you go away from the Elm environment and create like a pure JavaScript implementation of it? I guess you would have to do that. But that is very frustrating when building apps. Here we do have a state concept where you basically just, you have a state which is undefined by default. So you can just give that an initial value. And then you have change state to change it, and then the component renders again. Now the point here is that in terms of this rendering, like all the components has like a reconciliation boundary, which is the component itself, which means that if a parent component tries to reconcile a child component, it won't actually reconcile it unless the properties has changed. And this is partly for optimization, but also just for predictability, so that you understand when your components actually reconcile. And I think that's important, because that's really tricky in React, understanding like when you set state inside a component or it updates because it depends on some state store. You don't know how deep that reconciliation goes. But here you do know that. And then we have like hooks is it's not hooks React hooks, but it's like special properties related to handling component specific stuff. So for example, onMount is a hook which runs whenever that element. It can be the component element itself, or it can be any element actually. Which runs this logic when it mounts, and then when it's destroyed or unmounted, it will run the logic in the return function if you give it a return function. So this is inspired by the hooks API. And yeah, it works really well, because typically you want to work on the whatever you do in the mounting, you want to reverse in the unmounting. So an example of that is using the reaction from Overmind, where we just call the reaction. In this case, we're pointing to the current page where we want to scroll the document body to the top whenever that page changes. And this returns a function, a disposer function. So this is the way you can express that, and it disposes when the component unmounts. But as I said, you can do that with any element. And then we have onEnter. This is actually not implemented right now. But initially I had this automatic transition handling. But what I want to do instead is make it a little bit more low level. So it takes a function that gives you the element, and then you can do whatever you want with that element. That being setting up some transitions, an animation, or maybe you want to use like I think it's called GreenSock or something, which is a very popular JavaScript animation library. And then you can return a function, and that return function receives an argument called done, which in this case we give to the onTransition end. So the done is called when it's done animating out the element. So this function is triggered when the element is about to be removed, but it waits removing the element until the done is called. And this is what, for example, GreenSock would also expect, to have a callback, like onComplete, I think it's called. But the point is that you wouldn't inline this stuff. You would typically write like fade in out, and then you would have that function defined somewhere else. So you would have like really clean code in your component, but a lot of power under the hood. Okay, so that's basically the state of the API now. Let's have a quick look at the DevTools. Like there's not much, like it should look exactly the same. So maybe it's just more interesting to go in and look at the code. So where should we go? Action selector is quite complex. Yeah, I don't know. It's actually, it looks exactly the same. The only difference from the React version is that I'm returning self here, and that I'm not using the hook, and I'm rather getting app state and actions in here. That is basically everything I had to do to refactor. And then we have things like, well, I think I did want to show you something here. Didn't I have like an onMount thing here? Yes, so for example here, with the input, I didn't actually know this, but it seems that when you give an input autofocus, that only works the first time. But React is actually overriding this behavior. So they have some logic underneath, which makes sure that whenever the element is taken out and in of the DOM, it will actually make sure that it has focus. But what you can do simply here is just onMount element focus. So whenever it mounts, you give it focus, which is kind of cool. Yes. Yeah, I don't want to spend too much time on this. It basically looks the same as I said, but yeah, you have the self element and the hooks for onMount and stuff. Okay, let's look at the implementation, because this is quite interesting. So it's not that much code. It's really like where I had troubles with this is just understanding how everything, like how should it actually work. It's not amount of code, but like what should the lines of code be. So the way SnapDOM works is that you have this patch function, and that's basically all SnapDOM is, like at its core. And the initial patch is on an existing DOM node, and then you give it like a virtual DOM node, which is the node created in the render callback, like you saw here in render. We give it a function which returns a virtual DOM node, and that's the one we get calling here. And then basically that's what you do with SnapDOM. You patch it at the top of your virtual DOM every time there's a change. But that doesn't work in complex applications. You need to optimize the rendering so that you can do rendering in between in the virtual DOM tree. And that is why we have a component concept. But basically this is all it does when you render. And then let's see, the create element is also super simple. What it does is just intercept the create element function of snubdom, which is called h. And it just checks if the tag is a function, because if it's a function, it's a component. And then we rather return a component instead. What we also do is that we normalize, because we're basing our API on React, so we have to normalize the data coming in so that it looks like React, or we convert the React version to like snubdom. The data structure underneath is a little bit different. Also, the way children is handled is a little bit different. So we have to make sure that works. Okay, but then we have the component itself. So it's like, 200 lines of code, where initially what it does is that it creates an element. As you can see, it uses the create element factory here. And it sets it up with some hooks, as they called, even more hooks, in snubdom. And then we create our own component. And this component object lives through the lifetime of the component. So it's shared between patches. And this was kind of a tricky thing to do, keeping that reference. But as you can see, it doesn't pass in any children here. So it only creates the component node itself. And then whenever a parent tries to patch this component, like reconcile the element itself, we can intercept it by using a pre-patch, which is a snubdom thing, where we get the old node and the new node. And then I do some stuff here to produce what we need to update it. So basically what happens here is that, let's go down here. We can actually go to the bottom. So if nothing has changed, like no props has changed, or it's a reconciliation from the parent, but nothing has changed, we just copy the content of the old virtual DOM node to the new one, which basically means move the children over. It's the same, but you have to now understand, like, this V node will be the next old node. So it needs to have a reference to the children and stuff. But if, for example, there were some changes to the keys here, to the properties, then it would actually start up a tracking behavior. It would call the component function, pass in the new properties, pass in this Overmind context. It would then stop tracking, and then it would rather copy this new node over to the next node in the patching process. Now, what really threw me off here, which caused some weird bugs, was this concept of moving children. Because it's really difficult mentally to understand what is actually this old V node and what is the new V node. And I also have a current node that the component references, and understanding which is which and what triggers what, that was very, very difficult for me to figure out. But I did figure it out. So this is reconciling from the parent, and then you have reconciliation from the inside. So when the component initializes initially, you have the same concept where we start tracking, we create, we call the component function, we stop tracking, and then we copy this new node over to the component node that is being created currently. And then whenever there is a on flush, we actually use the patch again, but now we're patching the current node, the current component node, with the current component node. But we're changing its reference so that it's considered a new node, and we give it a flush ID, which identifies for the patching process that this is indeed an internal patching process. So that is what's happening in pre-patch here. Here we check if we have a flush ID or if we have a force update, which is related to a state change. So here it understands that, okay, this update came from the inside of the component, and then it basically does the same thing. Yes. So I just wanted to show you this, and then of course when we destroy, we make sure that we dispose the tracking tree and stuff. Okay. Yes, I guess that's it. I hope this made some sense and was an interesting insight into how it works. I'm not sure about performance yet. We need to get this into the next branch of Overmind and get it deployed so that we can actually compare it. But the goal is not to have like supersede React with amazing performance. That's not the point. The point is to explore this concept of having an external state store first, like primarily have that, and then you see, okay, this is where I build my app, but I want to present this in a view. How simple could this view layer be? As a secondary thought kind of thing. So the I've been refactoring this, and the development experience is really, really awesome, because you just reduce the amount of stuff you have to think about implementing everything. Cool. I hope that was okay. I have to fix some tiny things here. You see the color is a little bit off here because I had to change how SVGs are put into the project, as that was based on React. I also have to bring back the splitter because that was also React specific. But after that, I will put it into the next branch, and I will shout out on Twitter that you can try it out if you want to. And this is not a replacement for React. React does so much more than what this library does, but most projects are really only about creating HTML and updating when there's a state change, and then you have something that React doesn't do very well, and that is doing these tiny element manipulations, which I think the view layer should be excellent at, because that's what you want your view layer to work on. It's the UI itself, the elements, the experience of the user. All the state management and logic and stuff, that, in my opinion, that doesn't belong in a component at all. It just makes things so much more complicated. Yes, great, thanks. Talk to you later.